This is Ms. Black, and this is Open Campus for College Algebra, and we are now in Module 14D. So in this module, we've been working on graphing curves. We've already graphed a circle and an ellipse. So our third curve today is called a hyperbola, and we're going to see how the hyperbola relates to both the circle and the ellipse and how to graph it. All right, let's look at our notes. So if you look at your notes, ladies and gentlemen, if you look here, there are two pictures of a hyperbola. What I want you to notice is a hyperbola, just like a circle, just like an ellipse, is two curves. But instead of the curves coming together, now they're going apart. They're facing opposite directions. They're repelling each other. So a hyperbola is a picture of two curves. So you can't just draw one curve to make it a hyperbola. It's got to be two curves. And the two curves could split horizontally and go left and right like the first picture. And the two curves could split vertically and go up and down like the second picture. Now, the parts of the hyperbola we're going to deal with are every hyperbola has a center. The center is going to be the distance in between the two curves, the point in between where they're splitting from. Okay? If you look at both of these pictures, the center would be at the origin 0, 0. Because if you plotted 0, 0 and moved to the left and right, you'd be the same distance of those two curves. And on the second picture, if you plotted the origin 0, 0 and you moved up and down, you'd be the same distance those two curves. So every hyperbola has a center. And we're going to use the same letters to represent the center, just like we did with the circle and the ellipse. So the center of the hyperbola is going to be H and K. Now, to draw a hyperbola, you're only going to plot 2 points, not 4. So the 2 points we plot for the hyperbola are called the vertices. Those are the points that are actually on the curve. And if you look in the first hyperbola, those two vertices are sitting on the x-axis because that hyperbola is split left and right. On the other picture, the two vertices are sitting on the y-axis because that curve split up or down. And then they have what they call a transverse axis. And that's the axis that connects the two vertices. So those are our parts of our hyperbola. Okay? Now, what I want us to do is recognize by looking at the equation that we know we're going to be graphing a hyperbola. So let's look at what the equation of a hyperbola looks like. Oh my, if you look, there are two equations of a hyperbola. Now don't get nervous. They're pretty much the same equation. They both have an x minus h squared. They both have a y minus k squared. They both have an a squared. They both have a b squared. Both equations equal 1. So what I want you to notice is that these are not linear. These are x squareds and y squareds, which means two curves. Just like the circle, just like the ellipse. They both have the h and the k, which represented the center. So just like the circle, just like the ellipse, the h and the k are going to tell you where the center of the hyperbola is. That's a point we're going to plot to move from. A squared is still underneath x. That's the distance we're going to move left and right. B squared is still underneath y. That's the distance we're going to move up or down. So what is the difference with these equations? Well, if you look, they're not connected by addition. They're connected by subtraction. And that's why the two curves go apart. If you think about the circle and the ellipse, it was x squared plus y squared because the two curves came together. Now the curves are going apart, so that's why there's a minus. So you will know it's a hyperbola because you'll see x squared minus y squared. But wait a minute. The second equation of the hyperbola is y squared minus x squared. Why do we have to have two different equations? Well, think about the operation of subtraction. If you go back to elementary school and middle school, if I say 3 minus 2, would that mean the same thing as 2 minus 3? No, it doesn't. When you subtract, it matters who goes first. So the same is true with graphing. That first equation starts out x squared minus y squared. That means when our hyperbola splits, we're going to split across the x-axis, and the curves are going to go left or right. On the bottom equation, the y squared is first, which means when the hyperbola splits, it's going to split up the y-axis, going up or down. So if you look at our picture again, if I go back, that's why there's two different hyperbolas. If the x squared's first, it would split left or right like the first picture. If the y squared is first, then the hyperbola is going to split up and down like the second picture. And that goes back to the whole concept that in subtraction it matters who's listed first. Now, to graph a hyperbola, we have 4 steps. We got to have the equation in the correct form, which it is. We're going to write the center out. We're going to get our 2 distances, A and B. But we're going to do something different with those distances to graph the hyperbola. So even though we're going to get the same distances we got with the ellipse, we're going to use them differently to graph. So let's go to the whiteboard so I can explain the steps. All right, ladies and gentlemen, here we go. Here's my equation. X squared over 9 minus y squared over 4 equals 1. You know it's not linear. It's not a line. They're squared. You know because both the x and the y are squared, it's got to be 2 curves. They're not coming together this time because of the minus. The minus means the 2 curves are going to split. The problem is now, do they split left and right, or do they split up and down? You will know that by looking at the equation. If the x squared is first, you are guaranteed that these curves are going to split left and right and make a hyperbola that goes left and right. And I give that hyperbola a cute name. I call it my tree trunk hyperbola because that looks like the trunk of a tree. So, if the x squared is first, it's going to split left or right. To graph a hyperbola, you need the same 3 pieces of information you need to graph an ellipse. You need the center, distance A, distance B. The center is always after x and y, and again we discussed this. There's no number being subtracted with the x, so that must have been x minus 0 squared. So the h value is 0. There's no number being subtracted behind the y, so that must be y minus 0 squared. So your k value is 0. So if you do not see anything being subtracted from the x or the y squared, you can assume the center is always the origin. So I'm going to plot it. Just like the ellipse, you're going to get me the 2 distances. A is always going to be underneath x. B is going to be always underneath y. A and B are going to stay in that order. So my A distance is going to be the square root of 9, which is 3. My B distance is always going to be underneath y. So my B distance is going to be the square root of 4, which is 2. Okay? Now, here's the difference. When you did an ellipse, you just went from the center, left and right 3, up and down 2. You can't use these numbers the same way. We don't want to graph an ellipse. We want the curves to go apart. The way you decide which of these distances to use first is the one that's located first in the equation. It's not the one you write first on paper. You go back to the equation because x is first. We know this hyperbola is going to split left and right. That's why we're going to use distance A first. So from the center, we're going to move 3 to the right, 3 to the left. Those are your vertices, your 2 points on the curve. Now, we're ready to draw the curve, but we got a problem. A hyperbola curve can be really wide. It can start here, go all the way through here, and come out here. Or it could be very narrow. It could start here, come through that point, and go out. There's lots of ways to make you decide how big to make this curve. Do you make it wide? Do you make it narrow? I could do a lot of math and make you memorize a lot of formulas, but there's no need to that. I'm going to show you a way to cheat. on how to decide how wide or how narrow to make these curves. What we're going to do is we're going to draw in some imaginary boundary lines. And these imaginary boundary lines have a special name. They're invisible. They're not in the picture. So because they're going to be invisible boundary lines, we're not going to draw them solid. You're going to see them drawn broken because they're invisible. They're really not there. These boundary lines have a funny name. They're called asymptotes. Asymptotes. Now, how do you draw them in? Well, think about it. Out of our 3 pieces of information, we've already plotted the center, so we use that. We've already used distance A because it was listed first in the equation. So there was our distance A, and that got us our vertices. So the only thing we have left is distance B. Normally, we would move distance B up and down because it's underneath the Y. But normally, we move distance B from the center. Well, that's not going to work because it's going to make that ellipse. So to draw in the vertices, you take this other distance, and you're going to move it up and down. But you're going to move it from the 2 points you just plotted, the vertices. So what we're going to do is we have our vertices plotted. From the center, we move 3 to the right, 3 to the left. The curve's got to go through there. Now, what we're going to do is we're going to take our other distance B, which has got to move up and down. And from this vertice, we're going to move up 2, down 2. From this vertice, we're going to move up 2 or down 2. If you do this correctly, you should see the box, the rectangle. To draw in these invisible boundary lines, they are going to go from one corner of the box through the center to the other corner. So this is what your boundary line is going to look like. And you make it broken because it's invisible. It's really not there. We are cheating. And we're going to go through the other one, right through the center. Now, by going through the center and these 4 points you plotted, that's telling you the curve cannot connect and touch those. All these are invisible boundary lines. You deal with asymptotes every day in your real life. Think about driving, people. What's on the road? Aren't there dotted white lines? Are you supposed to drive and put your tire on those dotted white lines? No, you're not. Those dotted white lines keep the boundary lanes. Keep your car separated from the other cars so there's no accident. If your tire touched those dotted white lines, you would cause an accident and hurt somebody. That's exactly what we're doing here. We're drawing in boundary lines. That's going to help us determine how big to make these hyperbola curves. Because they're not connecting, we have no idea how wide to make them. Now everybody look. You've broken your picture into 4 places. 1, 2, 3, 4. The hyperbola curves, remember there's going to be 2 of them, are going to have to go through these points. But it's not going to start all the way out here now because it can't touch the asymptote. The asymptote keeps your boundary. So what you're going to do is follow the asymptotes. So the first curve's got to go in here. It's going to start out here, following the asymptote. It's going to go through that point and then curve back out. And now you're going to do the same thing on the left side. You're going to start by the asymptote, but don't touch it. Curve, turn back out. That's how you'll decide how big to make the hyperbola curves. You cannot cross the asymptote, just like in driving. You cannot cross that line. You're not supposed to touch it. And that's the way we're going to cheat. Now, if you look, these asymptotes are diagonal lines. So you could be asked lots of questions. You could be asked to write the equation of these asymptotes, which would be y equals mx plus b, which we learned to do in Module 13. But that's all there is to graphing a hyperbola. The minus tells you the 2 curves are going to go apart. Whatever variable is listed first is going to tell you which way to split the curves. Because the x is listed first, we went right or left. You will know which distance to move first because it's the first distance in the equation. Distance A was listed first, So we went right and left first. And then this other distance is going to help us make the box to make the asymptotes. So now the only question we didn't answer here is the coordinates of the vertices. The vertices are the 2 points that are on the hyperbola. These are the 2 points you plotted. So one is at -3, 0, and one is at +3, 0. What do you notice about those points? Very good. They're also sitting on the x-axis, so we could also call them the x-intercepts. All right, let's try another one. I know it's a little bit crazy, but let's try another one. Let me erase your equation and all your information here. Let's erase our pretty picture. All right, and let's get another one. All right, so look at my next equation. My next equation is y squared over 4 minus x squared over 9 equals 1. All right, so I'm looking at that, saying, okay, it can't be a line. There's squares. We have an x squared and a y squared, can't be a line. It's not linear. It's got to be a curve. Because we have an x squared and a y squared, it's got to be 2 curves. Now here's the difference. The minus means the 2 curves have to go apart. The only thing that you're learning to graph with 2 curves going apart is a hyperbola. Now the problem is, when 2 curves go apart, they either can go apart left or right, or they can go apart up or down. Don't sweat it. The equation is going to tell you which way to split them. Just look and see what variable's first. The y squared is first, which is telling you this hyperbola is going to split going up or down, like the y-axis. And I have a cute name for this. I call this my smiley, frowny hyperbola, because it looks like a smile and a frown. But that's why that's important. That first variable is going to tell you which way to split the curves. Now, the 3 pieces of information we need to graph a hyperbola are the same 3 pieces of information we needed to graph an ellipse. We need the center, distance A, distance B. The center is h and k. It's always behind x and y. Do you see anything behind x? Understood to be a 0. Do you see anything behind y? Understood to be a 0. There's no h and no k listed. It must be 0, 0. So we will go plot the center. Distance A is always under x. Distance A always goes under x. Here's distance A, because that's x. You're going to take the square root of 9, you're going to get 3. Distance B is always underneath y. Don't listen to the book. Don't listen to anybody else. Follow my lead. I'm giving you something that's easy to memorize. Distance B is always underneath y. Distance B is the square root of 4, which is 2. To graph an ellipse, it matters. I'm sorry, I apologize. To graph a hyperbola, it matters which distance you move first. When we did the ellipse the other day, it doesn't matter whether you go across first or up or down first, because all the points are going to connect to make the oval, the ellipse. But to graph a hyperbola, it does matter who you move first. Again, the way you decide who you're moving first is you look up at the equation. The equation is giving you everything you need. Y squared is first, which means we're going to break this curve up or down. So we are going to move the distance B first. That's how you know which distance to move first. If you're going to split up and down, you got to move distance B. So we're going to do distance B of 2. So we're going to go up 2 and down 2. So our hyperbola curve has got to come through. Now the problem is, how big do you make it? Do you make it really wide or do you make it narrow? You don't have to guess at it. I'm going to help you. It's real simple on how wide or narrow to make a hyperbola curve. You draw in invisible boundary lines called asymptotes. How do you draw them in? You use the only piece of information that's left, this other distance. You said distance A is 3. A always moves left or right, but instead of moving it from the center, you're going to move it from the 2 points you plotted. From this point you plotted you're going to go 3 to the right, 3 to the left. From this point you plot it, you're going to go 3 to the right, 3 to the left. If you do this correctly, you should make a box. Now all you got to do is go diagonally across and draw in those invisible boundary lines, asymptotes. For your hyperbola, every asymptote you draw should look like the letter X. When you draw in that asymptotes, these points are covered up. They're gone. That's why the hyperbola will never touch those points. The only thing the hyperbola should touch are these 2 points. So now you know, look at this, I got my hyperbola curve. It starts out here, it follows the asymptote, it gets really close, it goes through the point and curves back out. And you put arrows because it goes on forever. Now you do the one down here. You follow the asymptote, you get really close, you just don't touch it. You touch that point. Your hyperbola's got to go through this point you plotted, and you curve back out. And that's your picture. And the only question we're going to ask you about your hyperbola are, where are the vertices? Where are the 2 points you plotted on your hyperbola? Well, one's here at 0, 2. One's here at 0, -2. And if you notice, not only are they the vertices, they are on the y-axis. They're also called the y-intercepts. Okay? I think we need to try one more, don't you? All right, let me get one more equation for us to try. So let's erase this equation. Erase all our information. All right, so let me give you this equation. Let's see if you understand this. Y minus 1 squared over 4 minus x plus 2 squared over 9 equals 1. All right, everybody take a minute, look at that equation. Is it a line? No, can't be a line. It's not linear. It's not to the first power. You have x is squared and y is squared. So that guarantees 2 curves. So what you know how to graph now with 2 curves is a circle, ellipse, hyperbola. If there was a plus in between the x squared and y squared, that would guarantee the 2 curves coming together. And that could be either a circle or an ellipse. But because there's a minus between the x squared and the y squared, we're guaranteed the 2 curves are going to split apart. That's why we know this is a hyperbola. Just reason it out. Now that we know it's a hyperbola, we got to get our 3 pieces of information. We need our center, distance A, and distance B. Is the center this time going to be 0, 0? Well, no. There are numbers behind the x and the y. Now, this is important. The center of a circle, the center of an ellipse, the center of a hyperbola are always h and k. It goes in alphabetical order. H is behind x, k is behind y. It matters how you put the numbers when you write the center. The center is always hk, alphabetical order. So everybody look closely. This is your h, it's behind x. This is your k, it's behind y. H is always with x, k is always with y. So when you give me the center, you don't give me what you see, you give me the opposite, the additive inverse, just like we did for the circle, just like we did for the ellipse. So the center is your h value will be -2, your k value will be the opposite, +1. And we'll plot it, -2, +1. Very good? All right, we need 2 distances because it's not a circle, it's a hyperbola. I'm telling you, distance A is always underneath x. Here is x. So distance A is going to be the square root of 9, which is 3. Distance B is always going to be underneath y. Here is y. Distance B is going to be the square root of 4, which is 2. And yes, we try to give you numbers that are perfect squares so you can graph it nicely. We said Because this is a minus, it's a hyperbola, it matters which distance you move first. So everybody look at your equation. It's telling you what to do. The y squared is first, which guarantees this hyperbola is going to split up or down, and that's why you're going to move this distance first. If you're going y, that means you're going up and down. So we are moving distance b first. So our b distance is 2. So we're going to go from that center up to, down to. Okay? So the equation of the hyperbola, because it's connected by subtracting, matters which distance you move first. Whatever's listed in the first fraction is the distance you move first. Now we're going to use the other distance A, which is 3. We know distance A goes right or left. Distance A will always go right or left. But instead of going right and left from the center and making an ellipse, we're going to use that distance to make the box so we can draw a hyperbola. So from this vertex, we're going to go right 1, 2, 3, left 1, 2, 3. From this vertex, right 1, 2, 3, left 1, 2, 3. And X marks the spot. For your hyperbolas, those invisible lines called asymptotes are going to go diagonally. Now, those are boundary lines. Can your curve touch them? No way. Just like in driving, you're not supposed to let your tire go on the white dotted lines in the road. They're boundary lines. They keep everything organized. You now know your curve, how big it's going to be. When you go to draw it, you haven't drawn a hyperbola curve yet. You're not done. I don't see 2 curves. The first curve is going to be up here, and it's got to touch this point. Don't make the curve go above that point or below it. It's got to physically touch it. You're in between the asymptotes. Don't cross my asymptotes. Stay in between. Down here, a hyperbola's got to be 2 curves. So I need my other one. Touch your point. That's a general sketch of your picture. So now the only question I could ask you about this hyperbola is the vertices. Those are the 2 points you use to plot the curve. Well, the first vertices right here. That was at -2, 3. The second vertex is right here. That's at -2, -1. And that's all I need. Now, we can go into a bit more details. We could ask you to write the equations of these asymptotes, which they're diagonal lines. You'd have to figure out y equals mx plus b. We could ask you to find the x-intercepts and the y-intercepts. But if you look, will this hyperbola touch the x-axis? Well, if this curve keeps going up, 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 and this curve keeps coming down, 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 you're right. This hyperbola is not going to have any x-intercepts. Does this hyperbola have y-intercepts? Sure it does. It touches here the y-axis and here the y-axis. But because they're not touching at specific whole numbers, integers, you would have to find the y-intercepts by doing your work. You'd have to replace x with 0 and work this equation out and solve for y. So what we've done is we've now made a connection between the 3 equations that are made of 2 curves. X squared and y squareds are always 2 curves. If there's a plus, they come together, circle or ellipse. If there's a minus, they go apart, hyperbola. And then we learned what we need to graph each. We have one more curve coming up in the next module. Talk to you later.